For this problem, we're going to identify the property that is being used here in this equation. So I listed out the properties that we could choose from just to kind of go as a little bit of a review. So let's talk about associative. For the associative property, I want you to think of the word groups, because associative property is about changing what's in the group. Well, look at the groups we have. Notice we have a set of parentheses denoting the group y plus z. Okay, y and z are in the group. That's important. When we look at the group on the other side of the equation, y and z are still in the group. That's why this equation does not represent the associative property, because what was in the groups did not change. Y and z are in the group, and y and z are still in the group. Look at the commutative property. I want you to think of the word order. So when we look at the commutative property, the order can change. So notice inside of our group, we had y and then z, but over here we have z and then y. We changed the order, and that's why this is the commutative property. Let's keep going with the identity property just as a little bit of a review. I want you to think of 0 or 1 when you think of the identity property. We think of 0 because we can add 0 to get itself. If we have a number, we add 0, we still get itself. If we have a number and we multiply by 1, we still get that number. That's what the identity property tells us. Obviously, that's not going on in this equation. And then finally, distributive property. This is probably the one we use the most in algebra because it's new. We distribute the b by multiplying b times a, and then we multiply b times y. Now that's not going on here, so we know this isn't distributive property. So again, this problem represented the commutative property because the order changed inside the parentheses. We had y plus then z, but over here we had z plus then y.